Hello, 6th graders. Welcome to Big Ideas Math, Contract Math, Section 9.4, Volume of Prisms lesson. Pause while you write today's lesson in your math notebook. Pause again while you write the objective in your math notebook. This lesson's objective is find the volume of a prism using a formula. Example 1. Finding the volume of a prism. Let's look at our study tip over on the left. The area of the base of a rectangular prism is the product of the length and the width. You can use V, which is volume equals length times width times height, to find the volume of a rectangular prism. So let's go ahead and label our prism with our length, width, and height. Our 6 is our length, our 8 is our width, and our 15 is our height. Now looking at example 1, we are going to be using the length, width, and height, but it's going to look a little bit different over here, but it's essentially the same thing. We have V for volume equals base times height. Now, when we see this B here, we're looking for the base. So first we need to find the area of the base, and we do that by multiplying our length times our width. So 6 times 8, which we see here. And then our h, which is height, which we've labeled. So we multiply that by 15. So 48 times 15, and we multiply that and we get 720. So the volume is 720 cubic yards. In example 2, we are also finding the volume of a prism. So here's our prism for this example, and when we're finding the volume, we're finding the amount of space that this shape can contain. So let's look at our formula, the same formula, volume equals base times height. So we're going to start over here on this side, and this is a triangle, so we're going to find the area of the triangle, which is, we use our formula 1/2 of the base, which is 5.5, times the height, 2, and that's what we see here. And then we look over to the right, over here, and this is the height. So our 4 inches is our height. Now we multiply that out, we get 5.5 times 4. When we simplify, we get 22. So the volume is 22 cubic inches. Example 3, real-life application. A movie theater designs 2 bags to hold 96 cubic inches of popcorn. A. Find the height of each bag. B. Which bag should the theater choose to reduce the amount of paper needed? Explain. Let's start with letter A. Find the height of each bag. Bag A, we'll start with. So let's use our formula, volume equals base times height. Now we need to plug in our numbers. For V, which stands for volume, we need to go back up to our word problem and find where it says volume. A movie theater designs 2 bags to hold 96 cubic inches of popcorn. So our 96 is our volume. So that gets plugged in for V. And then we look at our base, which we see here. Length times width is our base. So 4 times 3. And we're trying to find the height. So we do the math, and we get 96 equals 12h. We want to get that h by itself, so we divide by 12 on each side, and we end up with a height of 8. So I'm going to put an 8 there. Bag B, same formula, volume equals base times height, and it says both of the bags hold 96 cubic inches. So there's a 96 here, and we look at our base and we see it's 4 times 4, and we're trying to find the height. So we leave the h there, and we multiply that out. We get 96 equals 16h. We divide both sides by 16 to get that h by itself, and we are left with 6 for our height. Moving down to letter B, here, to determine the amount of paper needed, find the surface area of each bag. Do not include the top base. So we're going to use our surface area formula here. And let's go ahead and label these out so that we can just plug them in. So we have length, width, and our height is labeled. And then length. Alright, so let's plug in our numbers. We have for our bag A, our length is 4 and our width is 3, plus our length is again 4 and our height was 8 we found. And then we go to our width, 3, and the height is 8. And we get 12 plus 64 plus 48, and we add that up, and we get 124 inches squared. Now moving on to bag B, same formula, but we'll plug in our different numbers for bag B. Length times width, 4 times 4, plus 2 times the length, which is 4, times the height, which we found was 6, plus 2 times the width, which we look over at our bag and we see is 4, times the height, 6. And we add all those numbers up and we get 112 inches squared. So which bag should the theater choose to reduce the amount of paper needed? Well, we look and we compare the two numbers. We have for bag A 124 inches squared, and then we have bag B 112 inches squared. So the surface area of bag B is less than the surface area of bag A. So the theater should choose bag B to reduce the amount of paper needed. Your assignment for this lesson is to complete the On Your Own problems 1 through 3 on page 379 in your online Big Ideas 2014 book. Do the work in your notebook and be prepared to share your work during our next class.
Remember, to earn credit for viewing this flipped lesson, you need to complete your exit slip, come to our next class prepared with the journal pages or other work from the flipped lesson completed, be prepared with any work that was assigned in the flipped lesson completed, and be prepared with any questions you have for your teacher, and of course have a good attitude.